Now let us do the today's session. So in this session, we are going to discuss about some problems on cylinder, precisely the concept of right circular cylinder, what we have discussed in the previous class. Then we start the concept of conicoid. The standard definitions and some basic problems, we start with that. So that will be about our today's session. So before that, do you have any queries for the previous class session on anyone? Please tell. Any doubts on the previous class? Right. So let us begin our today's session then. So this is the problem. Find the equation to right circular cylinder whose guiding circle is this is the problem. Please take a note of that. After noting, please inform. Now, if you draw the picture for the given problem, it will look like, say, this is the sphere equation which is given here, and say that this plane is intersecting this sphere. Now what happens? You will get the guiding circle at this portion. Now considering this circle as the base curve, we will get the cylinder. So this is our right circular cylinder. So as and when we talk of the right circular cylinder, it must have the axis. So how we are considering the axis? We consider the axis as it is passing through the center of the sphere and perpendicular to the plane. This is nothing but the axis of the cylinder. Is the overall idea clear for everyone? Now what happens? In order to write the equation of the right circular cylinder, we should know what is the radius of the cylinder, and next one is what is the axis of the cylinder. That we need to calculate here. So what happens if you say this is the radius of the cylinder? So how to deduce this radius of that circle? Any guesses for anyone? Similar kind of thing you would have done in the spheres chapter. whenever you have a circle, here the circle radius is nothing but the cylinder radius. How to get it there? Yes, using the Pythagoras theorem. So here, this is nothing but the radius of the sphere. So what happens? Sphere radius whole square is equal to distance whole square plus circle radius whole square. So what we are doing actually? We are calculating the equation of the right circular cylinder where the guiding circle is formed by these two, the intersection of the sphere and the plane. So this is the respective diagram for it, and first we are trying to calculate the radius of the cylinder. It is nothing but the radius of the circle there. So from this you have circle radius whole square equal to sphere radius whole square minus distance whole square. And how do we calculate the distance there? We calculate the distance from the center of the sphere to the plane. So if you apply the distance formula, so here ABCD values are taken from the plane. X1, Y1, Z1 is nothing but the center of the sphere. Can you compute this value? Here the sphere center is nothing but the origin 0, 0, 0. And tell me that value. A, B, C, D are nothing but the values in the plane. X1, Y1, Z1 is nothing but the center of the sphere 0, 0, 0. So I will say that you will get the value as root 3. You accept it all? So, and what is the sphere radius? It is 3. On squaring you will get 9. So this value is equal to 9 minus 3 equal to 6. Therefore, circle radius is nothing but root 6. So circle radius is nothing but the radius of the cylinder here. So you have done with one thing. The second thing we have to do is we have to calculate the equation of the axis. So as we described earlier, the axis is passing through the center of the sphere and perpendicular to the plane. In other words, the axis acts as a normal to the plane. So if you write the equation of the axis, it is x minus 0 by 1 equal to y minus 0 by minus 1 equal to z minus 0 by 1. Nothing but x by 1 equal to y by minus 1 equal to z by 1. So here 1 minus 1, 1. As you consider, the DC values are proportional to these things. Hence, the actual DCs of the axis are nothing but 1 by root 3 minus 1 by root 3 and 1 by root 3. I think you know from 1 minus 1, 1, you will get this value. Will you agree? So dividing with square root of 1 square plus minus 1 whole square plus 1 square. So you will get 1 by root 3 minus 1 by root 3, 1 by root 3. These are nothing but DCs of the axis. So nothing but the values of L, M and N. Now we have the equation of right circular cylinder, Let us substitute the values there. So the equation is L into x minus alpha plus m into y minus beta plus n into z minus gamma whole square equal to L square plus m square plus n square into this is the value. So here just observe that this is the line perpendicular to the plane accepted. So what are the plane DRs? 1, minus 1, 1. The coefficients of x, y, z. That's why I have written the values. You got it? And from these dr values, I have written the DCs like this. Clear now? We can use drs also, the same thing. If you want to get it as specifically what are the actual DCs of the axis, we should write like this. Otherwise, we can do the problem with drs also, nothing wrong. Because we are saying that the DCs of the axis are proportional to this value. Fine? Right. Now here, LMN values are nothing but 1 by root 3, minus 1 by root 3, 1 by root 3. Alpha, beta, gamma are nothing but 0, 0, 0. And R square value is nothing but 6. Now you can substitute the values here. And you can compute the cylinder equation. It is just expanding the formula value. Right? However, we will take one more step there. So there you have substituting the values 1 by root 3 into x minus y plus z. This total value whole square is equal to L square plus n square is nothing but 1. The DC's properties. So 1 into x square plus y square plus z square minus 6. Now you are going to expand this one. And you will say that on expansion, you will get the value as x square plus y square plus z square I think plus xy plus yz minus zx minus 9 equal to 0. Maybe that could be the equation. Fine. That you can check with the answer. So don't concentrate on the answer. This is the actual thing we do. Writing the axis equation and substituting values there. So you please take a note of that. After noting, please inform. Right? So let us take the next one. Find the equation of the right circular cylinder whose guiding circle or described on the circle through the points as guiding curve. Please take a note of this model. The equation of the right circular cylinder described on the circle through the points 1, 0, 0, 0, 1, 0, 0, 0, 1. The circle is nothing but the guiding curve. Okay. So for this problem, the approach is very similar to the previous problem what we have taken just now. The main difference between the previous problem and the current problem is, in the previous problem, the sphere equation and plane equation are straight away given and their intersection is nothing but the circle and you have done the problem. Here, apart from directly giving the sphere and plane equation, he has given the points on the circle. Now what we have to do here to get the circle? It is nothing but we have to calculate the circle which is passing through the points. In other words, we have to write a sphere equation and a plane equation obtained by these 3 points. So that what happens, intersection of the plane and sphere is nothing but the circle. Okay? Are you getting the idea behind it? So here we have to understand that the circle is obtained by the 3 points. In other words, those 3 points are lying on the circle. So without knowing the base curve, we cannot define the cylinder, isn't it? So here my intention is, I want to write a sphere equation passing through the points, a plane equation passing through the points. So if you just observe that these are nothing but the intercepts made on the axis, so the equation of the plane is nothing but this is nothing but x plus y plus z minus 1 equal to 0. This is the equation of the plane. Taking that these 3 points as intercepts, they are in the specific form. And if you take that A, B, C are the given points, by adding origin to this, we will get 4 points. So we can find a sphere equation from the 4 points. I have given a formula. Whenever we have intercepts, the equation of the sphere OABC is given by x square plus y square plus z square minus ax minus by minus cz equal to 0. Can you remember this form? So here the intercepts are nothing but 1, 1, 1. So ABC values are nothing but 1, 1, 1. So you have the equation of the sphere is this: x square plus y square plus z square minus x minus y minus z equal to 0. So what it means actually, this is the sphere passing through the given points. This is the plane passing through the given points. So these 3 points are common to the plane as well as the sphere, which is nothing but the guiding circle. Okay. Now the remaining procedure is as usual, just like the previous problem what we did. Are you getting the idea? Any questions for anybody at this point? Why we have written the speed equation and the plane equation? To anyone? Right. Then the same formula we use, circle radius whole square is equal to sphere radius whole square minus distance whole square. Now, from the sphere equation, the center of the sphere is nothing but 1 by 2, 1 by 2, 1 by 2. Accepted? And if you calculate the radius of the sphere is nothing but, I will say, square root of 3 by 4, nothing but root 3 by 2. Please check with the radius formula. Square root of u square plus v square plus w square minus d. The radius formula. Now if you apply the distance here, I will make space here. The distance is modulus of ax1 plus by1 plus cz1 plus d by square root of a square plus b square plus c square. So here a, b, c, d values are taken from the plane. x1, y1, z1 is nothing but the center. So I will say that if you substitute the values there, you are going to get the distance value as maybe 1 by 2 root 3. Please check that. The distance value. If everyone is clear with the distance value, then we will write the axis equation. Please let me know if everyone is calculated the distance there. Right. Now, the axis of the cylinder is passing through the center of the sphere and perpendicular to the plane. So if you write the equation, it is x minus 1 by 2 by 1 is equal to y minus 1 by 2 by 1 is equal to z minus 1 by 2 by 1. So the point we are taking is 1 by 2, 1 by 2, 1 by 2. The dr values are 1, 1, 1 from the plane. So the actual DCs, if you consider, they are nothing but 1 by root 3, 1 by root 3, 1 by root 3. These are the actual DCs of the axis. Now let us substitute the values there. So we have to do one more thing there. We need to calculate the circle radius whole square, right? So circle radius whole square is nothing but sphere radius whole square minus distance whole square. You have calculated that already. It is nothing but 2 by 3. Now let us substitute the values in that. So L value, so 1 by root 3 into x minus 1 by 2 plus 1 by root 3 into x minus 1 by 2 plus 1 by root 3 into x minus 1 by 2 whole square is equal to 1 into x minus 1 by 2 whole square plus y minus 1 by 2 whole square plus z minus 1 by 2 whole square minus 2 by 3. So I have substituted the values in that one. So on simplifying, you will get the equation as x square plus y square plus z square. Then you have the value minus yz minus zx minus xy minus 1 equal to 0. This is the equation of the right circular cylinder. Fine. You please check on that. So everyone, please check the approach what we did actually. If any confusion for anyone, I repeat the entire thing, what we have done. Because these two are very similar models. I will say one more thing, that the problem what we have taken just now is given in the other pattern, that apart from taking 1 0 0, he has taken the values as a 0 0, 0 b 0 and 0 0 c. So by taking these values as the points on the circle, calculate the equation of right circular cylinder. This is the question asked in the previous questions. So that thing you can take it as a practice, because we do the same thing. Fine. So apart from taking 1 0 0, 0 1 0 and 0 0 1, you take the 3 points, the intercepts, and you write the respective procedure as it is like this. You please take it as an assignment. Now if you are clear with this chapter, then we start the new one, that is nothing but the conicoid. So what is that 1 by 4 there? So constant value is 1 by minus 1 by 4 for this one you are saying, right? Okay. So let us start the new chapter. That is conicoid, right? So with respect to conicoid, if you want to study its properties, etc., I will give the pictures in WhatsApp in tomorrow morning or today night mostly. You please check that. But earlier we start with the basic concepts and what we are doing actually there in the chapter of conicoid. So we consider the locus of the points which are on the surface. So you consider the entire locus of this surface, and we are calling it as the conicoid. The very name is given as conicoid. Why the specific word conic is, whenever you consider this surface, if it is intersected by a plane, the section is nothing but conic. That is why generally we are calling it as the conicoid, right? That was the definition of it. Clear? Why we are calling it as a conicoid? And it is a second degree equation in XYZ. Now, if we do transformation of axis, that is shifting the origin, then this entire big equation will be reduced to a small equation. So obviously you are going to get it as this is one model. Another model. This is another model. This is one more model, etc., etc. So what we are doing actually, by taking suitable transformation of axis, this entire thing will be converted to one of these equations. So if you consider the first one, we call it as the ellipsoid. If you consider this one, we call it as hyperboloid of one sheet. Because there is one negative sign here. Here you are saying, right? Yes. The power of z is 1 here. Right. And here we call it as hyperboloid of two sheets, because we have two negative signs here. And this thing, we call it as hyperbolic paraboloid. If you take plus here, elliptic paraboloid. These are the names for them actually. So I will give the list of equations in Telegram, but in our syllabus we get the questions only from ellipsoid, hyperboloid and paraboloid. That's it. And mostly questions are there on ellipsoid and hyperboloid. Majority of the questions. So if you want a geometrical view, so in general we talk of that. If you take an ellipse, if you rotate this, you will get ellipsoid. Let me say, if you have taken the axis, the 3D axis, you fix a hyperbola at one end and you rotate that. On rotation, you will get the hyperboloid. So this hyperboloid is formed on one side. So we call it as hyperboloid of one sheet. If it is formed on either of the sides, we call it as hyperboloid of two sheets. So ellipse, hyperbola, parabola, we talk of them as 2D. Ellipsoid, hyperboloid, paraboloid, we talk of them as 3D. They were formed on suitable rotation. Clear? Yes or no? Right. Now, so we are going to do the problems on equations of this model, and we will do some problems on equations of the other model, what I am writing now. So we consider the equations of the form ax square plus by square plus cz square equal to 1. In a simple way, if you take 1 by a square is equal to a, 1 by b square is equal to b, 1 by c square is equal to c, this thing will come. So this thing we call it as central conicoid. An equation of the form ax square plus by square plus cz square equal to 1, we are calling it as central conicoid, where a, b, c are nothing but the coefficients, the real numbers. If all the coefficients are positive, then it is an ellipsoid. Among ABC, if one value is negative, it is hyperboloid of one sheet. If two values are negative, it is hyperboloid of two sheets. If all the three values A, B, C are negative, such type of system does not exist. So there could not be any such locus. Okay? Right? So since the very word central is there, so the conicoid will possess a center. Generally it is origin. We can call it as central conicoid with the other definition that if all of its chords through the origin are bisected at the origin, right? If all the chords of it are bisected at the origin, so that's why we are calling it as the central conicoid. And generally, this notation we call it as the standard notation of the conicoid. You please take a note of it. Right. Now, so whenever you take a point x1, y1, z1, if you want to calculate the tangent plane at this point, it is nothing but so for this we give the notation S1. And if you consider the ellipsoid, what we have written earlier, so if the given equation is of this form, we write that tangent plane equation as this is the equation of the tangent plane. Right? Now, suppose we have taken the central conicoid and I have considered a plane. So here T stands for distance from center to the plane and LMN are nothing but DCs. This type of notation we call it as the normal representation of the plane. If you want to know that whether this conicoid has the plane as tangent plane, what is the condition we need to check? So if you want to verify whether the given plane is a tangent plane to the conicoid or not, so what is the condition we need to verify? The condition is L square by A plus M square by B plus N square by C is equal to P square. You take a note of that. And the point of contact, if you talk upon, it is that is the point of contact. Now actually for these formulae we have standard proofs. Since our aim is to solve the problems and related concepts, so we are not discussing about the proofs. What are there actually? Okay? Clear? Right. And as I mentioned that P is the distance. So from this very notation, we can say that P is nothing but the value. If you want to calculate the distance from center to the plane, this is the distance value. L square by A plus M square by B plus N square by C. This is the distance value from center to the plane. And however, if we have taken the ellipsoid, and if you want to know whether this plane is a tangent plane for this ellipsoid or not, so what is the condition we need to check? For that, the condition is A square L square plus B square M square plus B square M square plus C square N square equal to P square. This is the condition there. You take a note of that. So if you have noted this, then let us do some basic problems which will give you an idea in solving the problems. So I am giving the overall view for this conicoid. While moving deep into the problems, we will have good discussion. Shall I continue then? Right. So this is the problem. Find the equations to the tangent planes to 7x square minus 3y square minus z square plus 21 equal to 0. So which pass through the line So please take a note of this. Then we'll discuss with the approach. Is it noted? Right. Now, here these two are nothing but the planes and they will intersect. It is nothing but a line. And this is the conicoid equation given. Generally, we observe that whenever the conicoid equation is there, is it in the standard form or not? That we need to understand. So, is it in the standard form? Say, So the standard form is nothing but ax square plus by square plus cz square equal to 1. That is the standard form. Or you can take the other thing also as x square by a square plus something is equal to 1. So what happens here? I will divide with the constant 21 and I will take the constant to the right hand side. So the result is nothing but x square by minus 3 plus y square by 7 plus z square by 21 is equal to 1. This is the standard form. Clear now? How I have written? By dividing with the constant. Then we have to calculate the tangent plane and understand that the tangent plane is passing through this line. So here, if you treat that these two are nothing but the planes pi 1 and pi 2, so we have to use the formula pi 1 plus lambda pi 2 equal to 0, or you can say it is k, pi 1 plus k pi 2 equal to 0. This is the required tangent plane. So it is nothing but 7x minus 6y plus 9 plus k into z minus 3 equal to 0. It is nothing but 7x minus 6y plus kz plus 9 minus 3k equal to 0, or you can write it as is equal to 3k minus 9. So if we have known, please understand, here we need to understand that this is a plane and this is a plane. The intersection is a line. We have to understand like that. So I am calculating the plane which is containing the line. In other words, if we have a small visualization, let us say this is the conicoid. For this conicoid, I want to calculate the tangent plane. And how the tangent plane is given? It is passing through the line. And the line is given in unsymmetric form. Clear now? The visual part? Right. So, if we have known what is k value, then you are done. So, I have given a formula earlier to verify the tangent plane condition, what it is. L square by A plus M square by B plus N square by C is equal to P square. Agreed? The condition? So here L, M, N are taken from here. So L is 7, M is minus 6, N is K, and this is P. A, B, C values are taken here. So here A is equal to minus 1 by 3, B is equal to 1 by 7, C is equal to 1 by 21. Because we treat that in the form ax square plus by square plus cz square equal to 1, the standard form of the conicoid. We have to treat like this. So if you substitute the respective values here, you will get the value of k. So I will say that you will get the value of k as k is equal to -4 and k is equal to -1/2. You will get two values for k. So which results that substituting -4 and -1/2 here, you will get two tangent planes. So is the approach clear? The overall view? Yes or no? Right. So can I take the next model then? All right. So I'm taking the problem slowly and slowly because it takes much visualization initially for conicoid. As and when you adjust with the situation, then it is very easy to understand the part. Show that the plane so the plane touches the conicoid and we have to find the point of contact here. It is very similar. I have given a formula to calculate point of contact and a formula to verify whether the plane touches the conicoid or not. So applying these two formulas, you can check that whether it touches the conicoid or not. And here, while solving this problem, we will do in a different way. So I have given that a formula for tangent plane equation. So if you consider this conicoid, say x1, y1, z1 is the point of contact. Let us assume that. So let us assume that the given plane touches the conicoid at the point x1, y1, z1, which is the point of contact. If I am able to determine the values of x1, y1, z1, then I am done. So that by default you have shown that it will touch the conicoid because the point of contact is existed here. So the tangent plane for the conicoid is 3x x1 minus 6y y1 plus 9z z1 plus minus 17 equal to 0. This is the equation of the tangent plane. I think you take the equation of conicoid here as plus 17. I will take plus 17. If this is the tangent plane, then these two must be same. So if you compare the respective coefficients are equal, then we will get the values of x1, y1, z1. So from this, if we compare x by x values, 3x1 by 3 equals to minus 6y1 by 12 equal to 9z1 by minus 6 equal to 17 by minus 17. Please check that. So if you equate each and every one with the constant value, you will get x1, y1, z1, nothing but the point of contact. So this is the other approach in order to calculate the point of contact. So what we have done actually, we have written the tangent plane equation for the conicoid. If the given plane is also a tangent plane, so these two must be same. In other words, they must have the same coefficient. So equating that the coefficients are equal, you will get the respective values of x1, y1, z1. That is the idea. You please take a note of that and give me the values of x1, y1, z1. I think it will be minus 1, 2, 2 by 3. That is the point of contact. You can do the either way. You can use the formula or you can use this technique also. Whichever is convenient, you can apply. Now we take the next model. Now let us go some problems just like theoretical. Prove that the sum of the squares of the reciprocals of any three mutually perpendicular diameters of an ellipsoid is constant. So you take a note of this problem. We discuss with the approach. After noting, please tell. Is it noted? Say. Right. Now, say this is the ellipsoid with the center. Now, what is meant by diameter here? The line, in other words, the chord passing through the center, we call it as the diameter. So, if you imagine the basketball, I will say, for the visualization of the ellipsoid, the basketball you take. So, you horizontally take a line, vertically you take a line, and diagonally you take a line. So you have three lines here. Horizontally, vertically, and diagonally. So every line passing through the center, every chord, we call it as a diameter. So there may be so many diameters. Among that, I am considering three diameters which are mutually perpendicular. And what the question is saying, the sum of the squares of the reciprocals, if you consider, it is nothing but a number. It is a constant. In other words, if you give some names, P, P dash, Q, Q dash, R dash as the diameters, so you have to prove that 1 by P, P dash whole square plus 1 by Q, Q dash whole square plus 1 by R dash whole square is equal to a constant. Sum of the squares of the reciprocals of the three mutually perpendicular diameters is a constant. This is our objective of the question. Is that clear? Any doubts you ask? Right. Now let us consider the ellipsoid equation. It is x square by a square plus y square by b square plus z square by c square is equal to 1. The equation of the ellipsoid. Since we have taken three diameters, let us take the DCs for them. L1, M1, N1, L2, M2, N2, and L3, M3, N3. So these are the DCs of the diameters, say P, P dash, Q, Q dash, and R dash. And obviously, the values you take them as R1, R2, and R3. The values you take them as. R1 is nothing but the radius for the first part, R3 is radius for the second, and R3 is radius for the third. Clear? So the diameters lengths are nothing but 2R1, 2R2, 2R3. The length of the diameters, P, P dash, Q, Q dash, R dash values. And by default assume that the center of the ellipsoid is nothing but origin, 0, 0, 0. So, as we have taken the DCs for it, what are the coordinates of P if you consider? Because L1, M1, N1 are the DCs for P, P dash, and R1 is the radius. So, the coordinates of P is nothing but accepted. Yes or no? Are you getting the idea or not? It is just like writing the parametric form. I will give you the idea how it is coming. Say this is center C, this is the point P. If you want to write the equation of CP, what is the form? Isn't it? Yes or no? The general form, if you want to write the line equation. So here the center is nothing but origin. So this is nothing but 0, 0, 0. And L1, M1, N1 are nothing but the DCs for the line. Now what happens? This is at a distance of R1. So this is nothing but R1 here. So what happens? X is equal to L1 R1, Y is equal to M1 R1, Z is equal to N1 R1, the coordinates of P. Agreed? From the parametric form you have written. Is it clear for everyone? Right. Now, please understand that, as you know, the coordinates of P is a point on the ellipsoid. So it must satisfy the equation of the ellipsoid. So if you substitute x, y, z values in the ellipsoid equation, so you have L1 R1 whole square by a square plus M1 R1 whole square by b square plus N1 R1 whole square by c square is equal to 1. The coordinates must satisfy the ellipsoid equation because it is a point on the ellipsoid. So from this, you can say that 1 by R1 square is equal to L1 square by A square plus M1 square by B square plus N1 square by C square. Agreed? Right. Now, I have taken one part CP. Similarly, you have CQ and CR values. Doing just like this, you have the part that 1 by R2 square is equal to L2 square by A square plus M2 square by B square plus N2 square by C square. Similarly, from the third one, you have 1 by R3 square is equal to L3 square by A square plus M3 square by B square plus N3 square by C square. These are the values. Now, I have to calculate the value of 1 by P dash whole square, 1 by Q dash whole square, plus 1 by R dash whole square. This thing I have to calculate. Sum of the squares of the reciprocals of three diameters which are mutually perpendicular. So, this is C, P and P dash. So, this is R1, this is R1. I know what is 1 by R1 square value. So, 1 by P dash is nothing but 2R1 whole square. So, 2R2 whole square, 1 by 2R3 whole square. So, nothing but 1 by 4 into 1 by R1 square plus 1 by R2 square plus 1 by R3 square. As you have known these values, you are going to substitute them. If you substitute 1 by R1 square, 1 by R2 square, 1 by R3 square values, you will get it as because the properties of this is, if you consider L1 square plus L2 square plus L3 square is equal to 1. Whenever you take any three mutually perpendicular values, the sum of the values is equal to 1. The properties of this is. So using this, you will have 1 by A square into 1, 1 by B square into 1 and 1 by C square into 1. So the result is nothing but 1 by 4 into 1 by A square plus 1 by B square plus 1 by C square, which is nothing but a constant value. So here we have proved that sum of the squares of the reciprocals of any three mutually perpendicular diameters of an ellipsoid is a constant. This is the problem we have solved. Please check with the approach. Clear or not clear? So the questions on ellipsoid chapter or the conicoid chapter will be of this model. So we have to understand the content of the problem. You have to visualize the problem task. Then based on the hypothesis, you are going to construct the things. So if you visualize that effectively, then it is very easy to solve the problem. Otherwise, as I have mentioned earlier, it just looks like a GS paper again, the chapter. So since we have started afresh, so let us conclude the session here. Tomorrow we are going to solve similar kind of problems more and more, which will be very interesting for you, right? Because I feel that you slowly adjust to this pattern to understand. Any questions for anybody? So if not, let us wind up now. So you are saying that the point of ellipsoid you are asking, right? What it is written actually there? Yeah, I will write. This is the ellipsoid equation. Point of contact here you are asking, right? I will just write. That is the point. That point is substituted here in place of x, y, z. This is the result. Now you got the idea how it is came. So if you have a small doubt, now this is half radius. This is the radius I have taken from one diameter. This is the other one, Q, I will take because P, P dash, Q, Q dash, R dash. So here the coordinates are L2, R2, M2, R2 and N2, R2. If you take the other one perpendicular, it will be L3, R3, M3, R3 and N3, R3. So that I will get 1 by R1 square from this part, 1 by R2 square from this part and 1 by R3 square from this part, substituting 1 and 1 point on this ellipsoid equation. So P, P dash is nothing but double the radius, the diameter value. So this is nothing but 2R1 whole square, 2R2 whole square, 2R3 whole square. Clear now? And I have substituted the values there. Now, if you visualize the content, now tell me what is the difficult part in solving a problem with regard to conicoid? As you have solved one single problem just now. It is just nothing but understanding the question tag, what it is actually asked. And what is the right equation you are substituting there. That's it. Then you will get the problem automatically. Nothing difficult at all in this. So if you understand the problem set correctly, then you are done. Fine. So any other queries from anybody with regard to this problem? If not, let us wind up our session here. Tomorrow we will meet with more problems on this conicoid. Thank you.